In this lesson, we are going to learn how to calibrate the response spectrum factor. First, let's display the base reaction. So, go to the results, then reaction. Now, click on the base reaction. So here, we can see the base reaction for all cases. Now, select the EX1 and the EX2 and the spec X maximum. Now, according to the ACI code, the base shear that has been calculated from the response spectrum function must be at least 85% of the calculated static base shear in the X direction or in the Y direction. So, let's find out whether the response spectrum function satisfies this condition or not. In our case, along the X direction, the ratio of the response spectrum base shear and the static base shear is 68.2%. So, we need to scale the response spectrum in the X direction to be more than 85%. So, I am going to scale it to be almost the same as the static base shear. And for that, I am going to divide the static base shear with the response base shear. So, the result will be 1.465, which means that I need to multiply the response factor by 1.465. Also, I am going to do the same for the Y direction. So, select EY1, EY2, and spec Y maximum. Now, divided the static base shear with the response base shear in the Y direction. So, the result will be 1.9. So, I need to multiply the response factor in the Y direction by 1.9. Now, let's unlock the model. Then, go to the load cases. Now, select the spec X. Then, click Modify Case. Now, multiply U1 and U3 factor by 1.465. Then click OK. Now select spec Y and also multiply the U2 and U3 factor by 1.9. Then click OK. Now I'm going to run the analyze procedure. We have finished analyzing our model. So here we can find that the base shear value in the X direction is almost the same in both static case and the dynamic case. Also, if we selected EY1, and spec Y, we can find that the base shear also almost the same. Next, I need to check on the torsion irregularity, and that's what I am going to do in the next lesson.